Welcome to Nandal. In this composite material structures under the first unit introduction to aircraft materials, we have discussed in the previous class titanium alloys. So in this case, in this class, we are going to study about alpha beta microstructure in titanium alloys and its significance. What are the properties in the alpha beta structures which is strengthening these alloys. Moreover, we are going to discuss the addition of vanadium into titanium alloys, how it improves the properties, in what are the ways. Those things and all we are going to discuss in this class. First, what is the significance of alpha beta microstructure in titanium alloys? Alpha beta microstructure in titanium alloys is significant because it provides unique combination of properties, including high strength, good ductility, high fatigue resistance, good creep resistance, corrosion resistance, weldability. In the high strength, in what way it will improve the property? What this property will focus on? This alpha beta microstructure offers high strength due to the presence of both alpha and beta pieces. Okay, it offers a high strength to weight ratio, that is high strength due to the presence of alpha phase and as well as a beta phase. So both alpha and beta phases, this microstructure involves giving more amount of strength. Then the alpha beta microstructure provides a balance between strength and ductility so that it will allow for some degree of reformation without failing. Once again, I'm telling you that good ductility. So ductile material means it will elongate and we can turn into wires or rods like that. Okay, so that it will allow some degree of freedom without failing. Okay, and also gives certain balance between the strength and ductility. That is a very important property. Next, high fatigue resistance. We all know that what is fatigue. So this is due to the repeated cyclic loading. There will be a strain induced. Okay. So due to repeated cyclic loading, the material will further strain. Like we are doing some work, initially we will do faster and faster. Then after repeated work, after some time we will tire. We cannot much efficient when compared to the earlier stage. So due to the repeated cyclic work, like other materials, how it behave, our body also behave like that. Okay, that is the fatigue. But it gives this alloy, alpha beta microstructure in titanium alloys produce or provides a high fatigue resistance so that it make it suitable for applications subjected to cyclic loading. And also it provides a good creep resistance, which is essential for high temperature applications. Okay, because when we are dealing with the engine parts and all, there will be a combustion. The process will take place by burning the fuel and oxygen. The high amount of heat is produced. That parts of the our combustion chamber outside exist, okay, like a turbine, those things and all, very hot, so that the temperature is very high. In those conditions, the materials to be used are high temperature materials. For that, this property will be very useful. This alpha beta microstructure offers a good creep resistance for high temperature applications. Okay. Then the very important one is corrosion resistance. Okay. This alpha beta microstructure also providing good corrosion resistance compared to single phase titanium alloys. But this is I'm telling that alpha beta alpha beta phase alloys. So it gives more amount of corrosion resistance. Then weldability. This alpha beta microstructure improves the weldability due to the presence of beta phase. Okay, not alpha phase, due to the presence of the beta phase in this structure, alpha beta microstructure, which helps to reduce the cracking. Reduce cracking. So that is a very important property. So high strength, good ductility, high fatigue strength, good creep resistance, corrosion resistance, then weldability. Those are all very important phenomena, and that are very significant in the alpha beta microstructure of in titanium alloys. Next, the addition of vanadium to the titanium alloys, how it improves the properties in what are the ways we are going to discuss. So the addition of vanadium to the titanium alloys improves their properties in several ways by increasing the strength, increasing and improved high temperature properties, enhanced creep resistance, refined microstructure, beta phase stabilization, corrosion resistance. Once again, it comes, okay, reduced alpha case formation. Okay, so vanadium additions increase the strength of titanium alloys. Okay, if you are increasing the vanadium, the strength of the titanium alloys will particularly increasing and at high temperatures. Okay, in the previous thing we considered the high temperature applications. So this vanadium, if you are adding, okay, it will be very useful in the use of high temperature materials. As also improved high temperature properties also improving. That is the important thing. It enhances high temperature stability of titanium. Okay, the stability to withstand the high temperature it will produce. So that there will be a risk reduction in the thermal degradation. Then, due to the creep resistance, what happens? If vanadium improves the creep resistance so that it allows the titanium alloys to withstand long-term exposure to high temperatures without a deformation. Okay. Then refined microstructure. In this case, this vanadium helps to refine the microstructure of titanium alloys, leading to improved mechanical properties and reduced grain size also. The grain size is very, very important. Okay. So this refined microstructure, in this vanadium helps to refine the microstructure of titanium alloys, which leads to the improved mechanical properties and reduced grain size. The mechanical properties, what we are talking about, the strength, corrosion resistance, ductility, malleability, workability, those all will come into this refined microstructure. Okay. Then beta phase stabilization. Vanadium stabilizes the beta phase in titanium alloys, which improves their strength, ductility, and toughness. It's all the mechanical properties. And important parameter already studied, discussed in titanium alloys also, the corrosion resistance, and in what way the vanadium it will be helpful for corrosion resistance. Here, vanadium enhance the corrosion resistance of titanium alloys, particularly in oxidizing the environments and reduced alpha case formation. In the earlier we discussing that beta phase stabilization. Here we are going to have a case of reduced alpha case formation. What is the importance in reducing the alpha case? So when vanadium reduces the alpha case formation, so a brittle surface layer that can form during heat treatment. Okay, a brittle surface layer that can form during heat treatment. It will occur generally, but it will reduce this vanadium. Okay, vanadium reduces the brittle surface layer. So these are all that things we have discussed. We are discussing in this topic in this class. What we have studied In this class, once again, I'm just recalling alpha beta microstructure. Okay, then what are the properties? Then we are having the alpha beta microstructure in titanium alloys. What are the importance and significant properties? How it will be helpful, and what are the improvements and developments? Then we have discussed the addition of vanadium to the titanium alloys towards the improvement of their properties and what are the ways, and how the beta phase stabilization happens, and the refined microstructure, how it will be effective towards the titanium alloys mechanical properties improvement, as well as the grain size reduction. Then corrosion resistance. Finally, the alpha case formation reduction. Okay, these and all we have discussed in this class. That's all in this class. We will discuss more about another topic in the next class. Thank you. Thank you for watching this video.